So they're giving us this graph of f prime. First off, make sure you're reading this carefully here, okay? The graph is of f prime. And they're giving me f prime while also telling me a whole bunch of areas in here. So we have, you see the areas between all these values. What that means is, remember this, the area under f prime, so the integral from a to b of f prime, is the change in f. Whew, look at that. So I'm writing on a weird angle here, but my handwriting is not that good anyway. Is the change in f on a to b. Cool, which is also the same thing as f of b minus f of a. That's what that means. So the fact they're giving me f prime with all these areas means we can find some extra values of f if they give us a specific value of f, and they're going to do that. And then they go ahead and they make up this whole new function g of x, which is dependent upon f, but it's got some weird function inside of it, like it's composed with a parabola in there, and then 5 minus 2x. All right, so they tell us the function f is twice differentiable. It satisfies f of 6 is negative 4, so this is a key piece for us. So now we know 1 point. Okay, and just to show you what that means, if f of 6 is negative 4, then right away I know that f of 10, and we can find other values. I'm just showing you one that's easy here. So if f of 6 is negative 4, and the area from 6 to 10 under f prime is 7 here and 4 here, that means f has to increase by 11. So it has to be negative 4 plus 11, which is 7. That's what that graph is telling us. All right, we can also go backwards. For instance, we also know that f of 4, and this is all kind of preemptive, me just kind of looking and showing you guys. F of 4, well, the area in here is really 3, but it's really negative 3, right? But we're going backwards, which is the trick. So you got to remember, you got to switch that area because we're decreasing 3 from 4 to 6, which means from 6 to 4, we're actually going up. So f of 4 is actually negative 4 plus 3, which is negative 1. And again, that makes sense because if f of 4 is negative 1, right, then if you go down 3 at 6, you will be at negative 4. And that's what's supposed to happen. And while I'm on this kick here, let's just go ahead and do this. We also know that f of 0 is, well, we know f of 4 is negative 1, and the area in here is 11, but I'm going backwards, right? So I have to subtract off 11. So f of 0 is actually negative 12. And I really, really urge you, if you're doing this on the AP test or for your homework, check this and make sure that this is making sense here. If I go from 0 to 4, I have to increase 11. Well, f of 0 is negative 12. F of 4 is negative 1. That happened, okay? That went up 11. Just double check it because it's super easy to add or subtract the wrong direction. All right. And the area down here is negative 5, which means f of negative 2 is going to be negative 12, because that's what it is at 0, plus 5, because we're going backwards. So that's negative 7. And again, if f of 2 is negative 7 and you go down 5, then you should be at negative 12 at 0, which we are. So that's what that whole graph tells us. It also tells us, again, I'm just kind of showing you all the stuff you should be thinking about when you see this question. 0 is going to be a minimum on f because the derivative is going from negative to positive. So we have, like, think about it like a number line like this. 0, 4, 6, 10. And the derivative, so f prime, right, is going negative, positive, negative, positive. There's another value in there where it's 0. It looks like it could be 9, but they don't tell us that. So I'm just going to say 6 to 10 is positive. Okay. Actually, that's probably not a great plan. Let's call that k, just because it's not really positive at k. So I'm going to say there's some value there where it's 0. All right. So that's all the information that thing tells us. All right. They also tell us f prime has horizontal tangents at 2, 5, 8, and 9. And if you recall that, horizontal tangents on f prime is the same thing as saying f has points of inflection there because the concavity is changing. So all that stuff comes back, hopefully, from all the stuff we talked about all year long. And they gave us all the areas. So that's what that whole prompt says. You should, really, again, read it really carefully, get all the information out of it that you can. And that's what that tells us about f. But part A asks about g. And it says, show that g is continuous. And our definition of continuity is this, gang, that the left-hand limit is at 3, right, of g of x, come here, you, has to equal the right-hand limit. That alone, I tested this a lot in the beginning of the year, that alone proves the limit exists. Right there. That's just, the limit exists. To show that it's continuous, you need the limit to exist, which means both sides are going to the same exact place, and we need that to equal g of 3. All right, so we got to find all three of those things here. The right-hand limit's easy because the right-hand limit is when x is greater than 3. So the right-hand limit, and I'm going to kind of squeeze it over here, but I'm going to do the right-hand limit first just because that's the easiest one. As we approach 3, get this out of here. From the right, we have equals the limit as we approach 3 from the right of 5 minus 2x. That's the function that we're on, and that equals -1. So that's the right-hand limit. The limit as we approach 3 from the left of g of x is exactly the same thing as the limit as we approach 3 from the left. We're on f, but it's f of x squared minus 5, which equals the limit. Actually, it just equals f of, if you plug a 3 into there, you get 4, which means we have to find f of 4. But we so smartly already found it. It was this up here. But we're going to have to show that work down here. We got to show why we know f of 4 is -1. Okay? So f of 4 is equal to, and I don't know if you guys remember this. You should remember this. You have a point on this function, -4 right there. Okay? So remember how we find other points? We actually have a definition for f. F of x would be -4 plus the integral from 6 to x of f prime of t dt. And that's something we did a lot with those rate in, rate out questions, right? We took the derivative, we integrated it, and then we added where we're starting. So f of 4 actually has to be -4 plus the integral. And again, we already know it's -1, so you could say that, but they're going to want to see you show some work. If you don't, you're going to lose a couple points. It's not going to be the end of the world. But this is how you would show that. So we got to integrate from 6 to 4 of f prime of x dx. And because the area between 4 and 6 right here is -3, the integral is -3, but we're going backwards. So f of 4 actually equals -4 plus 3, which is -1. So that shows that the right-hand limit and the left-hand limit are the same value. And then the last thing you got to show is that g of 3 is equal to f of 4, which we already found, which is -1. Okay, then you can write, so g of x is continuous at x equals 3. So that's all the work that goes into it. The main part of it is this right here. You got to remember this, and then they might make you do some weird stuff to find all that junk. But you got to have that written down somewhere, and then you got to check them already. 1, that's the first one. 2 was all this work here, and then 3. Then write a little sentence. Okay. Does somebody throw a question out here? What was that little bloop? Oh, damn. Okay. All right. Find the absolute value or absolute max value of f. We did spend some time doing this too. If you want to find the absolute value of a function on a closed interval, first thing you do, remember we said this over and over and over again, you got to show, hey, I know I need to find where is the derivative 0. Even if they give you all this information, you need to find that. Okay, you got to write that you're doing this. Now, we don't have to solve that equation. We already know the answers, but you got to write that you know to do it. So that's the first step. And our answers to this are 0, 4, 6, some value we don't know, and 10. Okay. And to justify our answer, to show that we're looking for a max, the only points we actually have to check that could be maximums are we're going to check the endpoints. Okay, so we're going to check, we got to check it. What's it say, from -2? Yeah. So we got to check the endpoints automatically. f of negative 2, and f of 10. We also got to check, so you can check all the critical values, but because I don't know what k is, I'm just going to check the ones where the derivative changes from positive to negative, since we're looking for a max. And I'm going to write that in a little sentence at the end. So the only ones I really need to check, and you see on our number line here, are 4 could be a maximum. You can see that on the graph too, right there, okay? And that's really it. So we got to check 4, and we got to check negative 2 and 10, which we already did up here. It wasn't hard to do. We just got to write out what we're doing in this question. This was all, again, like preemptive stuff that I was just kind of doing in my head. So we also have to check f of 4. So f of negative 2 is going to equal, same thing I did up here for my definition of f of x, which I should be using different colors here to be a little bit easier to see. That's what f of x is, okay? Again, that's taking the y value we know, chill computer screen, the y value we know, negative 4, and adding the integral from where we know it to where we want to know it, 6 to x. So if I want to know f of negative 2, that's going to be negative 4 plus the integral from 6 to negative 2 of f prime of x dx. And if you don't like integrating backwards, remember, if you switch the limits on your integral, which you can do, what that's really going to do is change the sign out front of that integral. So if you got areas and you want to integrate left to right, you can just flip the limits and change the sign out front. All right, so this is going to equal, let me get rid of all this junk here. Okay, that's going to equal negative 4. And all we got to do is find the areas from negative 2 to 6 now, okay, because I'm subtracting it off. So that is a negative 5, a positive 11, and we're going all the way to 6. So then a negative 3. So negative 5 plus 11 minus 3. All right, and what is that? Negative 4 minus, is that 8? 11 minus 8 is what, 3? So minus 3, so negative 7. Okay, is that what we found up here already? If negative 2, yeah, it was negative 7, okay. Cool. F of 10, we do the same exact thing. So that's negative 4 plus, actually minus the integral, oh no, we're going forward. So plus the integral from 6 to 10 of f prime of x dx. I hope this doesn't look like a bunch of like foreign language here to you guys. The integral from 6 to 10 though, so it's negative 4 plus, they tell us the integral from 6 to 10 right here is an area of 7 and then an area of 4. So that's plus 7 plus 4, which is 11 minus 4 is 7. Which again, we already knew, like we already did this. Like we know the max is going to be that 7, right? That's the biggest number that we found. But we still got to show all this work down here. Like we got to show why we know what it is. And then f of 4 is negative 4 plus the integral from, well, let's do subtraction because we're going backwards now, right? Minus the integral from 4 to 6 f prime of x dx, and that's just negative 4 minus the area from 4 to 6 happened to be negative 3, so minus negative 3. That's going to be negative 1. So the maximum is 7, and we're going to write a little sentence for that. Okay, so just to go through this process again, step 1, if you're asked to find the absolute max or min, is you show I know I need to find where the derivative is 0. Even if you're unsure how to do it, even if they ask it weirdly and you're like, I don't know how to do that, write it down, you'll get some points for it. Okay, that's the first step. Second step to that is really answer that question. Cool. The real second step, though, is to find the y value at all of those points that are possibilities. Either check them all or just check the ones that could be the max or the min. We just check the ones that could be the max, so I'm going to write this. All right, and I'm going to get my keyboard out because this should look a little neater than I can write. So let's get a bigger font here. Let's get a crazy big font. Let's go crazy. Let's go 36. Oh my gosh. All right, and you didn't. Okay. Very good. Very good, computer. I clicked out of it. Kablow. What? Yeah, 36. That's what I want. Come on, OneNote. Don't mess with me. Ah! Hold on. the maximum value. Let's do this. I don't know if you guys are laughing at me or are you laughing with me or at me? There we go. No, make this box bigger. Why is this so difficult? I don't feel like I have as much trouble with this. There we go. The maximum value of f of x. I'll just write it next time. Negative 2 to 10 is f of 10 equals 7. I checked the endpoints. X equals negative 2 and x equals 10, as well as where f prime of x changes. Now, before I just wrote where f prime of x was 0, but since I didn't do that, I just checked where it changed sign, positive, negative. I'm going to say, as well as where f prime of x changes from positive to negative. Whew. Okay. So that's a very, very standard question on the AP test. It always has been for, since before you were born. So you should be able to handle all those steps there. Again, they ask it weirdly, so we've been practicing that. But you should definitely expect to see that on there. Okay. C is a L'Hopital's rule question, and they kind of make it a little bit weird, just for fun. Okay. So it's known that they're saying, so k of x is some crazy new function, and it's known that we can use L'Hopital's rule here, which means when we plug 3 into this, we have to get 0 over 0. That's what that means. Okay? So that means the limit as we approach 3 of the numerator, which would be 3, the integral of 4, 3 to the x, f prime of x, or f prime of t, I guess we'll use. This one would be, oh yeah, dt. Boom, 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 minus 4x has to equal 0. And the limit as x goes to 3. We're going to handle both of these separately, but of 3e to the 2. I think this is a little bit more complicated than it really needs to be, but the point is important. So both of those have to equal 0. That's what has to happen. All right. But when you plug a 3 into there, this becomes 3 times the integral from 4 to 9 of f prime of t dt minus 12 has to equal 0. And if you solve that out, the integral from 4 to 9, do they ask us to find this? Find f of 3 and evaluate limit k to 3. Oh, so yeah, we have to do this anyway. Oh, we don't even have to do the top. I was kind of rushing along here. So because it just says find f of 3, which we can find from the denominator. It tells us to evaluate the limit, which means we're going to have to derive it. But this is what would happen. So this integral here, if you solve this out, those are t's, but right, that would have to equal 4. But we need to do all that because it tells us, it doesn't tell us up here. Oh yeah, it does tell us 4. Well, whatever. Oh no, it doesn't tell us 4 to 9, which is weird. Oh, yes, it does. I'm just rambling. The integral from 4, boom. So this is 9, I guess. The integral in there is 4, right? So that's what we just proved. But we didn't have to do that. And I was rushing and not paying attention because I got my eye on the clock here. But if we had to find what that integral was for some reason, that's how we would do that. Okay, but I hope it makes sense that we don't need that right now. We just know it has to be 0. We do need to solve this bottom one, though, because it says find f of 3. And f of 3 is in the denominator. So when you drop a 3 into that, you get 3e to the 2f of 3 plus 5 minus 3 has to be 0. Which means, luckily, if you solve this out, 2 to the f, or e to the 2 times f of 3 plus 5 has to equal 1 if you solve that, right? Add 3 over, divide by the other 3. So since that has to equal 1, the only way that can happen is if the exponent is 0. Okay? Because e to anything, putting back a 1, has to be a 0. So if 2f of 3 plus 5 is 0, that means f of 3 is negative 5 halves. Okay. So that's the first part of that question. The second part is evaluate the limit. So since we know we can use L'Hopital's rule, we can write using L'Hopital's rule, right? That limit becomes, and L'Hopital's rule just says, you can derive the top and the bottom, the numerator and the denominator. So this is kind of complicated, but let's write this out. I'm going to derive the denominator first because this top part has an integral. I'm going to go over how to derive an integral again. All right. But the derivative of e to a power, which is what we're looking at, is the same exact thing, right, times the derivative of the exponent, which in this case is going to be 2f prime of x. I'm going to write that out front. Okay? So that's the derivative of just that exponential thing. It's the same exact thing that's sitting there times the derivative of the numerator, and that's the chain rule, minus the derivative of that x, which is a 1. So that's what that becomes. All right? And if you remember, I'm going to take a little sidebar over here because we got to derive an integral to make sure that we all know how to do that, okay? So if f of x is, and let's just make this up, x squared to root x of some weird function in here, sine squared t dt, okay? First off, that means that f of 2 would be just the integral from 4 to root 2. That's what that looks like, of sine squared t dt, and that's just some number, right? Like we could drop that into a calculator. That's going to spit out a number. So that's why this is a function. I know it looks weird. It's got an integral in it, but it's just some function. You plug in an x value, you get out a y value. But we want to derive it. So the rule for deriving this thing is if you derive an integral, you get the same exact thing that's in the inside with a small catch. So the derivative of this, if you recall, is plug in the numerator times the derivative of what you plugged in, minus, not the numerator, the upper limit, minus plug in the lower limit multiplied by the derivative of what you plugged in. So that's the derivative of that function. Okay, that's our rule. If you don't know that, you should know that. Since way over here, we need to derive this thing right there. We're going to have to derive an integral. So the 3 is just there, right? We don't care about that 3. So when we derive the top, we get 3 times, and the derivative of that integral, okay, is f prime. I'm going to plug in the top limit times the derivative of what I plugged in, which is a 3. And then technically it's minus plug in the bottom limit, f prime of 4, times the derivative of what I plugged in. That's a 0. So that's the derivative of the integral, and then minus 4. So that's what we're dealing with. Shoo! So all we need to do is plug a 3 into this, right? We got to evaluate this. It looks kind of messy, but when you drop a 3 in, it's going to look a whole lot nicer. When you put a 3 in there, you get, so the top, the numerator is 3 times f prime of 9, that's the 3x with a 3 plugged in, times another 3. This whole part back here is 0. We don't need to worry about that. Minus 4 over 2 f prime of 3 times 3e to the 2f of 3 plus 5. Okay, so that's that, and then minus that 1. So what we need to know is f prime of 9, f prime of 3, and f of 3. We found f of 3 in this part down here, right here. F of 3 is negative 5 halves. Okay, f prime of 9 and f prime of 3, all the way up here. We have a graph right here. F prime of 9, even though they don't tell, this is kind of, do they tell us this? Oh, they do right here. F prime of 9 is 0, right? And f prime of 3, they gave us this point way back in the beginning, and I was wondering why we had that. F prime of 3 is 3.5. So f prime of 9 is 0, and we know that because f prime has horizontal tangent lines at all those values, and 9 is one of them. So that did tell us that this x value was 9. I was calling it k the whole time. but that's a 9. So f prime of 3 is 3.5. Let's drop all this junk in here. So f prime of 9 is 0. So this whole part here becomes 0, and the numerator is just -4. So do all that work just to get that. So on the bottom, we have 2 times f prime of 3 was 3.5 times 3e to the, remember, if you plug -5/2 in for f of 3, you're going to get e to the 0 minus 1. So this becomes, in the end, -4 over 2 times 3.5 is 7. And this is 3 minus 1, which is 2. So that is -2/7. Shoo! So, full disclosure, they could ask any one of these like questions we just covered, like can you derive an integral? Can you do L'Hopital's rule? Can you find a function based off L'Hopital's rule built off of it? Can you find a max and min? But I think this question is a little harder than what you might see on the AP test. Okay. I've also heard or seen, I can't remember, so much information floating around right now, that this test is supposed to be like, when you're sitting at your house taking this test, it's not going to be like you're taking a test in class, right? Like in terms of being able to finish it all and answer all the questions, like just like with the SAT, they have to make a test that not everyone's going to finish, that not everyone's going to be able to ace. Because if they make a test and all the kids are getting 100% on it, then it's kind of useless. Then you don't know like who was really doing better than everyone else. So they're going to try and make this test. I know they said there's an unlimited number of 5s and 4s, right? So like they're not going to curve it, but they are going to make it difficult enough so that like some kids aren't going to be able to finish, and some kids are going to struggle answering some of these questions because they just need to have a spread. They can't have everybody getting 100% on this thing. Okay. So anyway, even with that being said, I think that question was a whole lot more involved than anything you're going to see. I hope all the pieces make sense. You guys got to talk to me here. They usually curve it so that like the numbers of the percentages of 1, 2, 3, 4, 5s are the same, but they're not doing that this year because they're trying to convince kids to take the exam first off, and secondly, some of the BC kids are going to be taking the AB test because they got that option, and that's going to affect that curve probably pretty drastically depending on how many BC kids do that. So they can't sacrifice AB students like getting a better grade, you know what I mean, to the BC kids that are doing better because they've had 2 years of calculus, I think. So I'll have to double check that. I thought maybe you guys had heard that too, but the teachers were talking about that. I thought you all got emails saying something along those lines. But anyway, we got 5 minutes left. We're not going to finish this whole question. But let's just take a look at part D here. So the first thing that we're on the second page here is all the same stuff, right? But part D gives us the derivative of h for whatever reason. So they're making up some new function, and they're telling us that the derivative is this. And we know that y is above 1/3. Okay, the reason why they're telling me that is because, I don't know if you guys remember this, we talked about differential equations a little bit. We'll come back to that. It doesn't really matter. Okay, but yeah, I'll come back to that. Doesn't really matter right now. But this they have to say that, but for your purposes, it's not going to matter too much right yet. The first question, part D, says find the second derivative. So all that is we're going to use the chain rule. We have to use the product rule. So the second derivative of this thing, just follow along here. Okay, so we have two things being multiplied together, this and this. So the second derivative, derive the first thing, that's f prime of 2x. So that's going to be f double prime of 2x times 2. That's the chain rule. That's deriving this. The product rule says multiply by the derivative, or the second thing, not the derivative, just the second thing, plus leave the first thing, f prime of 2x, and derive the second. But the derivative of 3y, so it's not 1. Remember, the derivative of y with respect to x is not 1. That's definitely something they're going to try and trick you with. Make sure you know what variable you're deriving and what variable you're deriving with respect to. The derivative of y is dy dx. Okay, which, if you felt super snazzy about it, you could plug this whole thing in for that, because that's what dy dx is. Actually, we have to do that because they told us to find the second derivative. So we're going to take this one step further. This is 2 times f double prime of 2x times 3y minus 1 plus f prime of 2x times 3 dy dx, but dy dx was just what? F prime of 2x and 3y minus 1. So all I did there in that step to make sure is I took this part right here, my derivative, and I plugged in what dy dx is, where that is. Okay, so that's that. You don't need to simplify it. That's totally fine to leave it like that. You do need to plug in for dy dx. And it says, use the expression to determine if the graph of h of x is concave up or down at h of 1 equals 2. So here they're telling me the y value is 2. And to check if it's concave up or down, we just want to know is the second derivative positive or negative. So we need to know what this second derivative is. So we're going to plug all this junk in. So x is 1. So that's 2 f double prime of 2 times, and y is 2. So that's going to be 6 minus 1. So we can write this out. But you're plugging in a 2 for y. So that's 3 times 2 minus 1. And that's coming from, again, this point right here. So that's 6 minus 1, which is 5. Plus f prime of, you're plugging in 1 for x, that makes this a 2. Times 3 f prime, you're plugging in 1 for x, which makes that f prime of 2. And you're plugging in a 2 for y, which makes this a 5. So I need to know what that number is, if it's positive or negative. Just kind of a pain in the butt. So we need f double prime of 2. If you come all the way up here, check it out. Here's f prime. Right? At 2, f prime has a maximum, it has a horizontal tangent. That means the derivative of f prime is 0. That means f double prime of 2 is 0, which is nice, because it makes this whole thing go away. It's 2 times 0 times 5. So we just have one big 0 here. Plus f prime of 2, they tell us right from the graph. We got to look away up here, but f prime of 2 is 5, because that's off our graph. So we have 5 times 3, f prime of 2 is 5, and another 5. It doesn't matter what that is. That's definitely a positive number. Cool. So because that's positive, what do they call this thing? Just h. X is concave up. At 1, 2, since the second derivative of it is positive. Okay, that's that. What do we got? We're not gonna do this yet. This is all over the place here. We got to do E, and I'm going to do E and F here. I'm going to record it. You can hang out. So it says, consider the function h of x from -1 to 5. On what intervals is h increasing? Whew. So they're going to make things look weird for you, all right? But you know how to find where something is increasing. What that means is we need the derivative of h, which is dy dx, to be positive. Okay, that's the first thing. All right, the way we find out where things are positive is we make a little sign chart for them. All right, so our sign chart for dy dx is going to have everything that makes this thing 0. All right. Yeah, so man, I didn't get this far in doing this. I was like, I'll just do it with the kids. But that y there is messing with me here. What intervals is h of x increasing? Give a reason. Okay. Oh, so we don't need to worry about this. Because y is always greater than a third, this number here is always positive, if that makes sense. Okay. I was going to say, like, so we got to find where the derivative is 0. What threw me off for a second was this. We got to find where that derivative is 0. But that second piece, 3y minus 1, will be 0 when y equals a third. Now, that's not an x value. Like, that does not mean put a third on our number line, because the number line has x's on it. This is when y is a third, but y can never ever be a third, which means that thing can never ever be 0. So the only thing we got to worry about is, where is f prime 0? So f prime is going to be 0. You can see this at 0, and they gave us a weird interval too, didn't they? Yeah, from -1 to 5. So we only go to 5. So f prime is going to be 0 at 0 and 4. Okay, so the only numbers we got to worry about. However, one last trick they're doing is there's a 2x in there. So I know f prime of 0 is 0 and f prime of 4 is 0. But there's a 2x inside of there. So I know where 2x is 0 and where 2x is 4. That's such a pain in the butt. And that's going to happen when x is 0 and when x is 2. So 0 and 2 are going on my number line. Oh, man. Because we're going to 5, that can go out to 10. Oh, we have to check all of these. This is a dirty trick. Let me explain what I'm saying here. It only says -1 to 5, right? So I thought we could only go to 5, no problem. But because they put a 2x inside of here, that means we go out to f of prime of 10, which means we got to worry about all these dumb numbers up here. So we got to worry about 6 and 9 and 10. Well, and it's just 6, 6, and 9. But again, because we need that to be 6, we need that to be 3, and equals 9, that's going to happen when we have, 9 halves, which is 4.5. So on this number line, it's going to be a 3 and a 4.5. And that seems like a lot, because it really is. We need to check these intervals, okay? So -1 down here, 5 is up here. Keep in mind, the derivative is only two things being, right? F prime and 3y minus 1. This thing is always positive. 3y minus 1 is always positive. So the only thing that dictates the sign of this thing is f prime. And f prime goes negative, positive, negative, positive, positive. So this goes negative, positive, negative, negative, or negative, positive, positive. That's what we got going on there. So if you're with me at all, I feel like I'm definitely losing you guys in some of this. Again, I think this is more complicated than it's going to be in terms of like figuring this stuff out. The big important rule that I want you to keep in mind is that to find out where something is increasing, you just see where the derivative is positive, and you do whatever you can to find that. All right? As long as you show you know that, you're going to get some points. I don't think it's going to be this confusing. I like these questions. I just think they're a little much. But your answer is going to be, it's increasing on, and just list all the positive ones, 0 to 2, 3 to 4.5, and 4.5 to 5, because h prime of x is greater than 0. Whew. Okay, and you got to write somewhere too that I'm sure they want this. Look, I'm using dy dx and I'm using h prime of x. You got to write somewhere that h prime and dy dx are the same thing. Okay, and then last but not least, it says solve h. So this is a differential equation. Here's our derivative right here. And I told you to solve a differential equation, you need to separate the variables. Well, that's not super hard to do. When you do that, it's going to become dy over 3 minus 1 is equal to f prime of 2x dx. We need to integrate that. So we're going to integrate this side, we're going to integrate this side. Both of them require a u substitution. So here, on this side, u has to be 3y minus 1, which means du has to be 3dy. We don't have a 3, which means I got to put a 3 here, which means we got to put a 1/3 out front. So this integral is not hard. It becomes 1/3 1 over u du. And just to finish that out, that means this side is going to become 1/3 ln of u plus c. Okay? On the other side, and that's going to be equal to the other side, okay? Keep in mind, this is the end result of that. Well, we don't even need the plus c over here because we're going to put the plus c on the x side. Over here, we needed a u sub. I'm going to call it w, though, just so I don't use the same variable again. W is going to be 2x, which means dw is going to be 2 dx. All right, now we don't have a 2, so I got to put a 2 in here and a 1/2 out there. I have to do a u sub because the inside is that 2x, and that's something multiple choice wise they would definitely try and trick you on. But that means that integral becomes 1/2 the integral of f prime of w dw, which is just 1/2 f of w, which was 2x plus c. Okay, and you see how they say to leave your answer like this? So basically we have this box down here equals this box down here. So I'm going to give myself some room up here and write that. And all we're going to do is solve for how they want this thing to look. But the important part is to separate and integrate. That's all we did. Get the y's on one side, get the x's on the other side, integrate both sides. So I have that 1/3 ln of u, which was 3y minus 1, is equal to 1/2 f of 2x plus c, which means, since they just want me to have ln of 3y minus 1 over here, which is what we have, when you multiply by 3, you're going to get 3/2 f of 2x. And technically, it would be plus 3c, which is fine. But since c is just some number, 3c is also just some number, so they might leave it like that. But there's nothing wrong with putting a 3 there. Whew. But that's how you would answer that question. Okay. That was killer.